Alright, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Language Fundamentals course, I am doing a series of video presentations based on the textbook for the class, which is, as you can see on the screen, Muroc C# 2015. And there are 26 chapters in the book, and so far I have completed all of the material for Section 1, Section 2, Section 3, Section 4, and half of the material for Section 5. So I've got left 1, 2, 3, 4 chapters. So right now I'm going to go into how to use LINQ. For the entity framework, I'm going to talk about it, but I'm going to link to, no pun intended with link there, some presentations I did for the ASP.NET class at Rankin Technical College. So, Chapter 23, as you can see here, is on how to use LINQ. And if somebody said to me, can you give me LINQ, I don't know, in a sentence. LINQ allows you to basically use anything as though it was a database. In other words, not just a database, but an array, a collection, a list. You could take any of it and use LINQ syntax to basically run queries against it. Like I said, that's my definition, be it good or bad. So we've got one applied objective here, and I believe there's 9 knowledge objectives. Our applied objective: use any of the LINQ features presented in this chapter to query an in-memory data structure, such as an array, a sorted list, or a generic list. Knowledge, in general terms: explain how LINQ is implemented. Name the interface that a data source must implement to use LINQ. Describe the 3 stages of the query operation. Describe how the type of a query variable is determined. Describe how deferred execution works. Describe when a query operation results in a projection. Describe when a query operation results in an anonymous type. Describe the purpose of the following LINQ classes: from, where, order by, select, and join. Explain how extension methods and lambda expressions are used with LINQ. All right. It says some of the C# clauses for working with LINQ. Well, when you look at these, all right, if, you know, and I've shown you this earlier, but I'm just going to throw it up here anyway. Where is it? Here. We used something like this before, where we said if we wanted to go and grab something from an SQL or other type of database, really any kind of SQL database, select followed by 1 or more field names, from followed by 1 or more table names, where followed by 1 or more, something that we wanted to put in there to probably not have every record show. Well, the reason I'm telling you that is when you look here, well, look, from, where, order by, select, join. These are all things you've seen before. All right, one thing to realize with LINQ is, to my knowledge, LINQ is a Microsoft product. As it says, it's a query language that's been integrated with C#. It provides IntelliSense, which is nice. IntelliSense is the way that the Visual Studio editor works, and it can typically try to think of what it is you're trying to do, and usually a guess is right. Compile time syntax checking, so if you type a query in incorrectly, you'll know right away. Debugging support. The same type of basic syntax for each type of query, and designer tools that create object relational mappings. So here are the 3 stages of a query operation. Number 1, get the data source. As already mentioned, most people that I know of that work with this stuff aren't using it with databases. They're using it with arrays, lists, collections of objects. So as they mention here, if the data source is an array, you must declare the array and then assign values to its elements. Number 2, define the query expression. Number 3, execute the query to return the results. I have had people tell me before that in their humble opinion, that using this, if we look at the example right here, is kind of like SQL turned on its head. All right, so notice what we have here. We've got code that defines an array. So we're creating an array with 6 members. And it looks like they'll be the values 0, 1, 2, 3, 4, and 5. All right. Then we're writing here a link statement. All right, so we've got this thing called numbers. This is a temporary variable we're declaring on the fly. So from number and numbers, what it's doing is it's saying take the number, divide it by 2, and if the number has a remainder of 0, meaning it's even, then order them in descending order. Select number. So it looks like, since these, it's going to have 0, 1, 2, 3, 4, 5, the numbers that we're going to have are going to be 4, 2, and 0, and it would be in that order if it was descending order. So that's sorted even numbers, and there you can see it. Again, the key thing with this is you are using similar syntax to regular SQL, and you are writing database-like statements, but you are writing it on non-databases. So here we've got an array of decimals. It's got 4 decimals in it. You can see them right there. And a statement that defines the query expression from sales. Again, sales is a temporary variable we just created. Sales totals is the array. Select the sales. And it looks like we're adding them. All right. So here's an example that it says uses a generic list of invoices as the data source. So an invoice has an invoice ID, a customer ID, an invoice date, a product total, a sales tax, a shipping amount, and an invoice total. All right, then we come here and we're going to have a list of these. Okay. So we want to be able to select them, each one. And again, add the total. Where, just like the where in an SQL statement, it allows for filtering to take place. So notice before we asked for all of the sales. We were adding all of them. Now we only want the ones that are greater than 2,000. We've all done things like this before. For example, if you say something like you've got a 4-year institution and I only want upper class men and upper class women, so I only want it where grade or whatever you want to call it is junior or senior. Here's a query expression, as it says, that returns invoices with totals over $150. The idea behind this is, hopefully, by the time we get here to this point in this chapter, you will have done enough database queries that this should almost be second nature. Notice that the word order by is one word, where in SQL language it's 2 words. All right, so we're ordering it by default in ascending order. And you can see it. Here we're ordering by customer ID and invoice. So if they have the same ID, invoice total in descending order. So we've got 2 IDs that are the same. And notice these, the invoice amount is in descending order. All right. Make sure they don't let time get away from me here. I'm at 10 minutes, so I can go a little bit longer. 2 ways to code the select clause. Select columns or select something new. So here's an example that selects key values. select sales.key. So, an employee list from sales where sales value is greater than 2,000. Order by sales.value in descending order. Select sales.key. And key basically has been set up over here to be named. Alright, so who do we have in descending order? Should be Thompson, Menendez, Wilkinson, Anderson. And Anderson is not over 2,000, so Anderson is excluded from the list. You can also have a query expression that creates an anonymous type. With an anonymous type, basically it's an unnamed type. Alright, you can use join syntax. Here is an example as it says that joins data from two different generic lists. So we've got here a customer who's got an ID and a name and an invoice. And we want to join the customer on, and notice as always we have to have a field that's in common. Invoice.customer ID, it equals, it's the word equals, not an equal sign. Customer.customer ID where the total is greater than 150. Here's the code as mentioned that executes that query. And here are your results. An extension method that extends the string data type, a class with an extension method that formats a phone number. Well, we all know this. This will take this and set it up as what? Looks like periods here, so 559.555.1212. All right, some of the methods that are used to implement common clauses, well, we've already seen these. You'll notice they look virtually the same as their counterparts in LINQ, except that these are in uppercase. All right, I'm going to stop right here. I don't have much to go, probably only about 10 slides, but this seems like a good place to stop, and then we'll talk about lambda expressions as we finish this up in just a couple minutes.